My contribution, as Neil said earlier, I'm going to embark on a bit of a scene setter for you. In a very summary fashion, I'm going to take a very quick canter through the evolutions of sustainable building design, and primarily to highlight aspects of that which are prevalent and relevant today, and how we're now recognizing and relearning some of our skills and understandings of the past. It's based on a personal view. It's not AECOM's view. It's my view. 25 odd years of practice around the globe, and a little piece of research I undertook, academic research I undertook a few years ago. This one. Okay, hand drawings by me.
Pretty good.
So when mankind first moved from the caves or the bush and started to build purposefully dwellings, primarily, that's it, natural materials were obviously used. Home Depot and Lowe's were not around. You had what you had. There was no power available, clearly. So the natural environmental condition, benefits and the challenges associated with that had to be respected. We designed to take full advantage of the positive qualities of our local environment. Self-shading, prevailing wind, thermal mass, elevated structures, those sorts of basic technologies and practices were applied very relatively successfully. We stayed close to water as a source of water for drinking, cooking food, a source of food in its own right, and eventually for means of travel. As we grew in numbers, the local environment was still wonderful. The sun still shone, the birds still sang. Very difficult to say that. Apart from the fact that most people died in their 30s, slavery was rife, and mankind was pretty awful to each other, life was okay. But eventually, hamlets became villages, became towns. Natural resources were still used, but the immediate resources in any particular vicinity had been consumed, were already used. So we had to travel further. There was still no Lowe's or Home Depot. Peat, wood, coal were used to heat, primarily in the northern climates, and cook food. Oil was a source of fuel for additional lighting when needed, which meant that we had to come up with cunning plans to how to deal with ventilation, and we invented things like the chimney. And our buildings became slightly more complicated than they hitherto used to be. Transportation and transit routes became more important, particularly around waters and rivers. But the river water we were finding, due to the growth in number of people, river water was getting slightly less pleasant. The built environment was getting busier, a little more complex. Pressures on resources spurned innovations, all manner of innovations across society. Apart from the occasional weather-related crop failures, mankind was actually eating more healthily. There was more calories were being consumed. People ate more, we started to live longer, and there became more of us. The sun still shone, the birds still sang. Life was getting better.
Ooh.
Did you draw that as well?
No, that one I grabbed. That one I grabbed. Economic and production structures became interwoven with our society and the fabric of society. More of us were starting to live in more urban environments. Agriculture was becoming more effective, not quite commercial yet, but becoming more effective, so it could feed many more of us. Science was beginning to eradicate some of the diseases that had hitherto reduced our numbers. Other diseases were coming along. War was still prevalent. We were still being rather unpleasant to many of our colleagues on the planet. Pressure for land grew. Density increased as an obvious response to that. One of the key challenges we had was how to deal with the waste from all that congregated human activity. Air quality, water quality started to suffer. The sun still shone, except for 1315 to 1317 in northern Europe, where apparently it rained for 3 years.
Wow.
Dreadful. Birds were a bit quieter because they were a source of food. Apart from pigeons, they were starting to evolve quite nicely into the new environment that was available to them. But things were developing. Then came the industrial miracle. It gave us back concrete. For a millennia, we'd forgotten concrete. We lost it after the Roman Empire collapsed. The French came up with a rather cool idea about how to reinforce it. We're inventing steel beams, plate glass, eventually elevators, and air conditioning. Things were developing on a number of technology fronts. We got clever at designing buildings, much clever. We had to. Buildings were getting more complex, the need for the buildings, the systems that went into creating the buildings became ever more complicated. About this time, the building professions started to splinter into areas of focus or expertise. Whereas historically the architect had been the designer and the master builder, now we were starting to see on the design side that there was a segregation between those who construct and those who design. Challenge. There was also the design function was splintering as well. So architects took on one part of it. We saw structural engineers, we saw mechanical engineers. At the turn of the last century we started to see electrical engineers. Then we had cost consultants and project managers. And today we've got sustainability consultants. So a very complex mix of specialist expertise which is applied to the building professions. Societal pressures continue to increase with greater demand for resources, land particularly. We needed more functioning utility from the land that was available, so density continued to increase. Villages became towns, became cities, became mega cities, or very large cities at that time. We also started to demand, quite rightly, greater utility from our buildings. They needed to do their job better than they hitherto had been able to do. Unfortunately, about this time, we were also starting to realise that environmentally our buildings were not performing in the way that they should do. They were designed in a way that relied on what we thought was the saviour of the time, which was limitless, benign fuel that enabled us to heat, cool, light, and do whatever we wanted in the building, regardless of the form, the structure, where it was, how it went together. But the sun still shone. Occasionally there was an acrid cloud which might drift across the front. The birds clustered in the few remaining trees, but life was okay. Whereas, I didn't draw this one. Whereas major civic buildings, such as the big pieces of architecture in years gone by, the cathedrals, the mosques, they would take centuries to build. Society was now demanding that significant buildings appeared in a matter of years. We often spend longer with the permitting and funding arrangements of a building than we do in designing and delivering it today. Around this time, we also invented sick buildings. We didn't invent it. We fell upon the notion, the idea. We started to realise that we had sick buildings, magnificent acres of glass and steel, which were not quite in harmony with their local environment. Leaked, actually. That was quite handy because it compensated for the fact that the air conditioning or the ventilation system was poor. But they were hot or cold, depending on the time of the year and where you were. They were uncontrollable. People were uncomfortable in them. And we overlooked the prime, fundamental, important reason why a building exists, and that is to give the occupants the very best opportunity to perform whatever task they need to perform in that building as best they can do. Buildings are there to support the function that's in them. When done right, the issues of fuel use, rental yields, and all that sort of stuff pales into insignificance with a marginal improvement on efficiency of someone in a school being able to teach slightly better, or a student learning better, in a hospital where a person heals quicker. Those are the big drivers, in my opinion. However, sun still shone, birds sang, but there were occasions when people were less comfortable in our buildings than we'd like them to be. There have been exceptions, but in general, the property industry have not quite got their arms around the broad sustainability issues that they needed to. We started to address that primarily and initially through the peak condition. So the maximum amount of energy, or the maximum temperature, or the lowest temperature. And we enshrine those in a codified approach broadly. Most jurisdictions around the world started with a codified approach So we insulated to code. We had limits on glass to code. Our values were to code. All good stuff, I'm not knocking it, a very important first step. Broad strategies were beginning to become well understood. Light and tight, mass and glass, which grew up as philosophies of construction or approaches in different parts of the world. And we were starting to accept and understand that we needed to respect the particular environmental area that that particular building was in and its function. For a short while we plugged all the leaky facades, air conditioning still didn't work well, and our sick buildings got sicker. But we've now begun to fully understand the holistic, interrelated aspect of what it takes to deliver a high performance building. We realise it's a balance, and society and the industry are now starting to respond. Today we're all familiar probably with, and these are just a snapshot of some of them, the broad sustainability metrics. LEED is the most commonly understood one here in the United States. We've still got codes, a very important part of it. Title 24, actually 90.1, depending on the jurisdiction you're in. But we're also finding that broad sustainability and codes are starting to come together. Cal Green is a good example of that. A very positive step, I believe. Performance-based solutions, as opposed to just a strict codified approach, we are starting to embrace and accept and understand what it means overall performance, annualized, as opposed to just the peak condition. July 21st, June 21st, December 21st, where you are in the world, those are not necessarily going to give you the optimum annualized performance. And indeed, when you do that, when you embrace that, the design solutions that come forward can be different, sometimes significantly different. In many cases, we're starting to relearn some of those old approaches that our ancestors knew well and understood. They might not have been able to analyze it to the same degree that we are able to today, and it might have taken them longer to build it, but we're understanding that far better. We're also beginning to understand a fundamental aspect of building performance. Buildings are here for a long time. They should be here for a long time. They embed a significant amount of resource and energy in their physical being. Foundations, superstructure, facades, big carbon footprints associated with that. They need to be flexible and adaptable so that over the full life of the building they can perform and support the function that will change inside them. Clients are becoming more aware. Federal mandates are a good example where the federal sector have got some pretty robust targets to try and achieve. The historic splintering of our building professions and the complexity of the buildings and sophistications that we now need to deliver today, we're relearning and having to reinvent some ways of connecting those different aspects together more effectively. We're understanding that performance of a building is far more than just a rental yield or a CO2 per square metre assessment. The sun's still shining. We embrace now far more, to a much greater extent, we embrace nature rather than exclude it. We've come an awful long way. We don't think we're there yet, but we've made good progress. Thank you.
Thank you.